students, myself Dr.A.Vaniprabha, Associate Professor, AC Department, working in SNS College of Engineering. Today we are going to discuss on three topics: total internal reflection, critical angle, and a few examples that explains better about these two concepts, right? Okay. Before discussing about total internal reflection, we should know what is refraction, right? What is refraction actually? It is nothing but a bending of light waves whenever a wave is incident at the interface. Whenever a wave is traveling from one medium to another medium, there occurs the bending of light rays. For example, we can consider here two medium. One is air, another one is glass. We all know air is a rarer medium when compared with the glass. Glass is a denser medium. We consider a light is traveling among these two medium. How it behaves? Consider for a case, air is the rarer medium and glass is the denser medium. Whenever the light travels from air to glass, what happens? Air is rarer medium. A light is traveling from air into the glass. What happens? Once the light ray exactly incident at the boundary of air and glass, it gets immediately refracted. That is, there will be a bending of light ray. When we draw a normal line between the two medium, then we can easily identify the incident ray is represented as I and the refracted ray is represented as R. What happens? How the refracted ray behaves when it travels from rarer medium to a denser medium? And consider the case 2. When a light ray is traveling from the glass to the air, what happens? Again, the same phenomena occurs. The light ray bends. Whenever light ray travels from glass and it enters into the interface of air and glass, immediately the ray gets refracted as shown here. Okay. So now from these two cases we can understand whenever a light ray travels from air to glass, what happens? There also the bending of light ray occurs. One thing we have to notice here is the refracted ray will be is closer to the normal line, or it is towards the normal line. Whereas in case 2, when the light ray is traveling from glass to air, the refracted ray moves away from the normal line. You can see the difference here. In the drawing also it is clearly mentioned for easy understanding or better understanding. Right. So the first case is the light ray travels from air to the glass and the refracted ray moves closer to the normal line. When the light ray is traveling from glass to air, the refracted ray will be moving away from the normal line. So this is the difference between when a light ray is traveling from one medium to another. Depends upon the medium quality. The refracted ray either moves closer to the normal or moves away from the normal. Okay, this is about refraction. Now moving on to the concept of critical angle. What is critical angle? For this also let us consider the same two medium, air and glass. And imagine a light ray is moving from glass to the rarer medium air. This is the drawing. that shows that phenomena. Okay. Again the same thing, the normal line is drawn exactly at the boundary. Once the light ray is hitting the boundary, it immediately gets refracted. When the light ray travels from glass to air, the refraction will be moving away from the normal line. Okay. If the angle of incidence of the light ray is slightly increased or varied, let us consider the light ray incident angle is increased from 20 to 30 or from some numbers, right? What happens? Again still the refracted ray moves away from the normal, and um, that angle also is increased. The refracted angle is also increased. And again, if we further move the incident angle, that is if we further increase the angle of incidence of the light ray at the glass medium, what happens? At one point, the refracted ray completely lies parallel to the boundary. Means it makes an exactly perpendicular angle between the normal line what we have drawn here. So that is shown in the picture clearly. So the angle at which the refracted ray makes exactly perpendicular to the normal is called as the critical angle. Right? So the next is the total internal reflection. We know what a reflection is. Whenever a light ray is incident on a medium, it reflects back, right? So here, what is total internal reflection? The same thing. Here we have to consider the critical angle also for better understanding. Again, two medium has been taken for consideration, air and glass. Whenever the light ray travels from glass to the air, refraction takes place. And if we know the critical angle of the glass is 30 degree or 42 degree. Whenever the light makes an angle 42 degree with the normal line, it gets completely refracted with an angle of 90 degree, right? If suppose the angle of incident of light ray is still further increased above the critical angle, what happens then? The ray is completely, totally internally reflected into the same medium. Whenever the angle of incidence is greater than the critical angle, then total internal reflection occurs within the same medium. So this is about total internal reflection. So for small understanding, see these two diagrams. The critical angle of glass is found to be 42 degree. If the angle of incidence is less than 42 degree, whether total internal reflection occurs? No, definitely not. Whenever the critical angle or the angle of incidence is greater than the critical angle, then there occurs the total internal reflection within the same medium. Okay. Some real-time examples, that is whenever light ray travels from water to air or air to water, based on the value of the critical angle, either it is get completely refracted exactly parallel to the boundary, or it gets completely reflected within the same medium, which is nothing but total internal reflection. And another from air and diamond. So the same is the phenomena, whatever the medium is. But only thing, the critical angle varies for every different material. For example, for diamond it is in the range of 20. If the angle of incidence is greater than that range, then the ray is completely reflected back. Total internal reflection occurs. Hope you understood this session. Thank you for listening. Thank you.